Okay, what are we doing now? Power connectors and cap. I think that's the next thing that I'll do. So before I forget, I'll change to a larger tip. Just used a really big one, T18D32. Now these should still reach, and because of the design of this Matek board, it has the notched input pads. How I combined two of these with one of the hexes was to place one wire in the notch and then the other on the side next to it, which worked quite nicely. So I think I'll do the same with this. So this is something I might end up redoing several times to get it just right. Or it might go right first time. I'm trying to remember how I did this before. I think what I probably did was that, and then put the tweezers around both wires and melted them, the whole joint again. So if I come down like this, get the whole flat side of the tip, there we go. That's what we want. So now we've remelted the whole joint, so we don't have one of them formed when the other one was not formed. Right, that's perfect. That's what we're going to do. Black wire's a bit shorter than the other one, isn't it? I mean, if it's worth doing properly, so maybe I will make that a bit shorter. If I take slightly more than that off. Just tack it in place, then you might be able to see it from there actually. Yep, that's worked beautifully. Maybe it'll actually be possible to remelt all of this with the cap and get the whole lot melted in one nice contiguous joint, rather than have the cap on top in a semi-melted separate joint. There we go, that works. Okay, so now we have two sets of wires and the cap, all in nice contiguous joints, no half melted joints where I've added extra things. This is just to remove the flux. Now that the joints are done, the flux serves no purpose except to make it look crusty and ugly. So we use alcohol to dissolve the flux. Right, zip tie that down. Okay, so that is power sorted. Let's do a quick test. Make sure that everything switches on, there's no shorts. So just using the bench power supply again, set to 16.8 volts with a fairly low current limit, 400 milliamps. If there's a short, I'll just see the value jump up to 400 straight away, and it'll stop. It's good. Peaked at 364, and now it's down to 104 milliamps, which is just the quiescent current for the regulators and that sort of thing, which should still work. 5 volts here. Yep, and 10 volts there, which we do. Now, my understanding about this PDB combined with the matching flight controller is that the ribbon connector will take care of 5 volts to power the flight controller, also battery voltage for voltage sensing, also the current sensor and ESC wiring. So I shouldn't have to worry about any of that, which is nice. All I need to do on here is tap off battery voltage and ground for the VTX, which is going to stay there. I can actually use the wires it's got, can't I? Does anything else need power? Buzzer will take 5 volts from the VTX, that's from the FC. Receiver will take power from the FC, GPS will take power from the FC, and that's it, isn't it? So yeah, that's all. Right, I might take a quick photo of this, just for posterity's sake and to stick on rotor builds. Okay, that'll do. So now we can actually put the flight controller on top. I don't think there's anything on the bottom I'll need. There's the SDA SCL for I2C, but I've ordered a different GPS to use. One without a compass. Let's quickly get rid of some of this solder that's poking through a bit too much. There we go. So I'll use a fresh ribbon cable because I've got a kink in that one and I don't want to use. Now I prefer the ribbon cables because they lock, but I prefer the JST of the member stack because it's silicon wire rather than a ribbon. I'm happy with that. Both of them are flat, straight. That's good. Actually, we can test that, can't we? 5 volts there, I think should be, yes, so it does power 5 volts. We've got VCC to VCC, ground to ground, all over the place. Can I see a signal wire? Where's signal 2? There. Yep, that works. So what have we got to do? We can do VTX first, I guess, because it's already there. So VTX is all the way on this side, which is quite annoying. Ugh, how do I do this? It would be nice to go through, wouldn't it? No, actually, it'll be better to take that on top, because then it'll be further away from the power wires. If I put this, which is a video wire from the FC, going to the VTX, if I put that between these two boards, then I'll have the analog video running right next to the switching regulators and the power for the ESCs. So actually I'll probably put it over the top like this, because even though it'll look messier, it will give me better, cleaner video performance. Just thinking about antenna mounting, because I was thinking about moving the antenna tail down to the bottom. There's a couple of issues with that. First is that how do I attach that unless I go side lengthways? I might go lengthways. So how am I going to do this?